How would you like your calls, on the rocks or stirred and shaken? So to give you a brief introduction about myself, I'm Ruchir Brahmbhatt. I'm the co-founder and CTO of Ecosmob. I'm also the co-founder of Hodusoft. So basically, I look after the technology advancement, R&D, and also I help my team with the right resources, tools, processes, and mentorship so that they can deliver the project successfully and we can achieve the customer delight. So basically, Ecosmob is a globally known brand when it comes to real-time communication solutions development. I will not bore you with the details. You can meet us outside to more about us. So let me ask a question to the audience. So if you get a call like this, I hope it's readable. How likely are you to pick up such call? Yes, no, can't say. You're not? Okay, I get it. So we have a very, very smart audience over here, but not everyone is so fortunate because someone calling maybe something like this. So let me tell you about a story that happened to my friend in the UK. So which shook me to the core, by the way. His wife got a call from his number one day, and there was this lady on the call. She presented herself as the police officer. She told her that your husband is detained in the fraud case. We know that he might be innocent, but in order to bail him, you need to do the bond of £3,000 immediately. So the wife tried to request her to talk to her husband, but the lady was so authoritative and she denied the request. Not only that, she forced her to stay on the call for 30 minutes, asked her to go to the nearest bank, withdraw the money, and then deposit to the nearest post office account. Only after dropping the call, she saw the message from her husband, which was sent during the same time the call was active. Only then she realized that she was being duped. They tried a lot to trace the transaction, trace the account, but it was nowhere to be found. This is just one of the millions of stories happening around the world. So let's look at some of the statistics over here. So if you look at the Truecaller's Insights 2022 US Spam and Scam report, more than 68 million people fell victim to the scams. 1 in 3 Americans reported having fallen victim, with more than 20% more than once, actually. The average loss reported was $577, and 61.1% of these people were scammed. So totaling all this, the total loss incurred was $39.5 billion, which is staggering. So can we do something about this? Can we do something about this online phone scams and spam? Can I get some ideas from the audience? Sorry? Yeah, and is there any solution to resolve this problem? Any suggestions? Any ideas? Sorry? Sorry? Oh, you don't answer the phone. Yeah, the vigilance, awareness, and common sense goes a long way, but not everyone can demonstrate all the time. But there are other alternatives as well, like there are some caller ID applications, for example, Truecaller, which helps you identify, it tries to help you identify the caller, but it doesn't, it's not flawless. It has its own limitations as well, right? So to begin with, it only works on the smartphones. It also requires active internet connection to detect the call. So till date, still a lot of calls are happening on the landlines or the IP phones where these applications are not effective. It relies on the crowdsourced database. So there is no central governing authority which can validate the authenticity of the data, basically, right? So it can identify the number, but it can't guarantee the authenticity. So that's another challenge. And interestingly, like same number, same call, similar calls can be spam for someone at the same time. It may be very important call for someone else. It happens to me all the time, often, if not all the time. So I get a call from the banks or financial institutions, and it is showing up as a spam because enough people have reported it as a spam because these agencies use the same number to do the marketing calls as well as informative calls, which is a very, very bad idea. And last but not the least, the data security and privacy, because they are storing all your contacts, your data is not so secure. So there is another alternative to it, enter stir shaken. So basically, it's a technology framework which is designed to reduce the fraudulent calls and caller ID spoofing. So there are two parts in it, STOR and SHAKEN. So STOR is for Secure Telephony Identity Revisited. So it aims to add the secure identity information to the call so that the endpoints in the network can verify the call. And SHAKEN is a secure handling of asserted information using the tokens. So it provides the mechanism to verify the call and how the information will be transported across the network. So it doesn't directly prevent the caller ID spoofing or the spamming or frauds, but it does provide a method using which you can know whether to trust the caller ID or not. And FCC are already mandated that by June 2021, all the service providers have to implement it. The deadline has gone already. Many have implemented, but not everyone has. So I'll try to give some more information on how you can implement it if you are starting a new business, becoming a new service provider. So basically, SHAKEN tries to restore the trust in the voice network, and that is how it will try to reduce the fraudulent calls, the caller ID spoofing, at the same time ensure that the legitimate calls can be reached to the right destination. So overall, how does the SHAKEN works? So whenever a user makes the call, the originating service provider does the authentication service in which it will create the passport, it will sign it, create the SIP identity header, add it to the invite, and then relay the call to the terminating service provider. And then this terminating service provider will do the verification service by validating the certificate and also decoding the passport and ensuring the attestation is right, the caller ID is what it claims to be. So, okay, let me ask the audience. So, doesn't it look very simple? You can get a domain name, you can get a certificate easily, you can start signing your calls. So the robocallers can do that as well, isn't it? How it can be foolproof then? Don't you think so? Well, not exactly. The process is not that simple. You might have got a glimpse yesterday's talk as well on the same. So basically, the service provider have to register to the policy administrators. So they verify that actually it's a genuine service provider, and they have to get the service provider token. Then they have to request the certificate from the certification authority by providing the token. And then they get the certificate, and then only they can start signing their own calls. So let's talk about the authentication service. How does it work? So typically, as a service provider, whenever the call comes to you, you verify that whether the call is from our own user or not, because the calls may be getting from some gateways or the enterprise PBX or somewhere, right? So you want to sign your end users only. So if it's not, you simply let the other call flow take over. If it is coming from the registered authenticated user, then you also verify if the identity header is already present or not. If it is there, you don't want to mess with it. You simply relay the call. If it is not present, then you can go forward for the authentication service, right? So what do? Basically, we have to create a passport. We sign the passport with the certificate. We add the SIP identity header in the invite, and then we relay the call to the termination service providers. So what is passport? So passport will look something like this. So there is a header and the payload. So the header part contains the algorithm, which should be always ES256. Then there is a PPT extension, which should be SHAKEN all the time. The type is a passport, of course. And the X5U contains the part of the certificate, which is used to sign the token. And then there is this attestation. Oh, it's messing up the format. Okay. So attestation type, which we'll discuss shortly. Then there is ordination and destination for the calling and the called parties. Then the IoT token, which is a timestamp when exactly the token was created. And the origin ID, which is the call ID. You can use the call ID or UUID over here. So what is attestation? There are basically three types of attestations, A, B, and C. So A stands for full attestation, in which case you can authenticate the origination of the call, and you can also authorize, you can know whether the calling party is authorized to use that number or not. So for example, subscriber registered to us directly, right? Then there is a type B attestation, in which case we can authenticate the origination of the call, but we cannot tell for sure if the user is authorized to use this number. So for instance, some extension in the enterprise PBX is making the call and the call comes from the PBX. So we know the PBX own the number, but the user who made the call, whether they are allowed or not, that only PBX knows. So that is a kind of type B attestation. And last is the C, gateway attestation, in which we can authenticate the origination from where the call is coming. We trust that party, but we don't know if the user who made the call is authenticated and authorized or not. So typically call coming from an international gateway, right? So how does the verification flow work? So whenever incoming call is received on the verification service provider, so we first of all check if the identity header is present or not. So here, there are multiple ways. Some providers, they can choose to keep it optional, whether to allow the calls without identity header or not, whether to do verification for all the calls or not. And even in that, you want to support all the attestation types or only certain, A only or A and B and ABC, everything. So ideally, A is preferable, but in certain cases, you may want to keep it somewhat flexible. So yeah, if the identity header is not present and if you are enforcing it, you reject the call straight away. If it is present, then you decode the passport, and then we check the attestation level in the passport. Now here, attestation level, we verify there can be system level configuration as well as user level configuration, whether you want to allow all the type of attestations or only specific ones, right? So if it is matching the criteria, then you can proceed for the verification. Otherwise, you can simply drop the call. So how we do verification is we get the SIP identity header, then we extract the passport, then we get the URL of the certificate, then we decode it, then we validate the certificate and verify the number, origination and destination to make sure it is what it is claimed to be. And then we only relay the call. So that's enough talks. Let's go through some practical implementation as well for the demo purpose. For demo, we are using this kind of architecture where the OpenSIPS is there. All the users are registering to OpenSIPS, and the calls are exchanged between the gateways, and we are using a cluster of free switch server. So please note that the authentication and verification service can be performed in all kind of servers. It can be OpenSIPS, it can be Camelio, it can be free switch, it can be Asterisk. So for demo purpose, we are using this kind of architecture. So what you need to do, and one more thing, we are doing both the authentication and verification on OpenSIPS only. So basically, you have to load the stir shaken module in OpenSIPS. You configure the auth date and verify date freshness, which is basically tells OpenSIPS whether to how much older the date header in the SIP invite can be for authentication and verification services, respectively. And then there is a CA list, which is the path of the file containing the certificates of all the authorized certification providers. Then finally, the required date header, which can be optional. If you keep it optional, it may get it from the SIP invite if it exists. If it doesn't, then it will get the date from the IoT token, which we discussed earlier. I'm not talking about authentication. Everyone knows how to authenticate a user. But you need to authorize, or you need to verify if the user is authorized to use that caller ID or not. So depending on your logic, you may do the database deep or memory deep to verify that part, and then go further. So then we validate the certificate. Now it's a good practice to cache the certificate locally because it's not going to change often. It may change 1 year or 2 years down the line. So you don't want to make too many requests to the servers, right? So we fetch the certificate from the local cache, and then we verify it from the stir shaken check cert function. So if it is not valid or if it doesn't exist, we should download it and again store it in the cache so that it can be used in the future. Then finally, we can perform the authentication service using the stir shaken auth function by passing the right attestation, UUID, origination, destination, private key, and the certificate path. For verification, first we have to check if the identity header is present at all using the is present HF function. If it is not there, we can drop the call. If it exists, then we can proceed further. So here again, we had the certificate path in the passport. So we try to fetch that from the cache again. And then if it is not valid, or if it doesn't exist, we download again, and then again store it in the cache for efficiency. And finally, once everything is in place, we use the stir, shake, and verify function. And then it will decode the passport, verify the attestation, verify the origination and destination. And if it is valid, then we relay the call. Otherwise, we drop the call. So we'll do a quick demo, practical implementation. So for the demo purpose, we are calling between the two users, and we'll try to simulate different scenarios like this. So second user is accepting the type A attestation calls only. And system-wide, we are allowing only the attestation, the stir shaken calls. And at the same time, we will try changing the caller ID and see what happens. So, so first we are going to make a call from a user using the caller ID which doesn't belong to the user. Okay. So I'm going to change. Okay, I'm going to call the second user. Okay. So here we see the call is declined, and with the message that the caller ID ownership is failed. So we don't allow the call as discussed. Now let's make another call using the caller ID with attestation type B. Remember that we discussed that the second user accepts type A calls only. So in this case, user A is authorized to use this number, but the attestation which will come up will be type B. Now let's call again. Okay. So we see we are getting declined again, and it will not allow type B attestation calls. That's the error message that we are throwing. Now let's test the final case in which we are going to use the valid caller ID with type A attestation. I'm going to accept the call on my phone. Okay, I got the call, it's connected, as you can see. Let's look at some of the packets as well. So this is the invite packet. You can see the identity header with the passport, with the certificate path, and the shaken extension. And as the caller ID is valid, the authentication is done, and the call is relayed further and verified as well. Okay. Yeah. So as we saw, stir shaken provides a very solid mechanism to authenticate caller ID, to verify it, and ensure the robocallers or scam callers, they cannot dupe the customers, consumers, and businesses. So doesn't it look like a silver bullet to all the fraud problems? Isn't it? Can't say that 100% sure, because it has its own limitations as well. So first is while it authenticates the caller ID, it cannot indicate whether the call is genuine or not. As I mentioned earlier, the vigilance, awareness, and common sense goes a long way. So I don't think any system would be able to prevent 100% of the time. And secondly, it works on the IP-based networks only. So if we are getting calls from a legacy systems, we will not be able to verify, actually. So as discussed earlier, it doesn't directly prevent the caller ID spoofing or spam or scam, but it provides a solid mechanism. So if enough providers implement the mechanism and the users are showing the awareness, so earlier they used to hit their head on the rocks while scammers were enjoying the drinks while having a last laugh with stir shaken in place. Finally, the scammers can hit their head on the rocks while users can enjoy their martini, either stirred or shaken. Thank you very much. I'll leave the floor open for any questions, and I'm adding some resources as well for future reference and further study. Should I stir it or shake it?